Hi guys, happy Monday. So today we're starting a new unit called Rational Exponents. It'll be pretty small, but it does include Module 64. So rational exponents are just when we have anything that has a fraction in the exponent. So like x to the 1/2, or 9 to the 1/2, or 36 to the 3/4, right? Anytime that we don't have a whole number right here, we just have a fraction. So we are going to deal with these today by turning them into radicals, right? We already know how to deal with radicals, right? Looking for groups of a certain amount. So we're just going to turn our exponents into radicals. So what we're going to see here is something like x to the 1/2 power. What happens in order to turn them into radical form is we take the bottom number, the denominator of the exponent here. We take the denominator and we kick it out to the back, right? We kick it out to become the index. Remember that this means that we're looking for, this is how many we're looking for. So groups of this many, right? So when we're breaking down this number x, we're going to look for groups of 2. Right? The top number gets to stick around and stay exactly where it was, so it's going to stay as the exponent of the x, or the base. Right? The way that I remember this is the number that's on top always gets to stick around. So if you're on top, you stay at the top. If you're on the bottom, you get kicked around a little bit. So that 2 gets kicked out in front. So it's easier to see this when we think about it in the context of real numbers. So let's start with one. We're going to look at this one right here. So we have 8 to the power of 1/3. Right? So I'm going to see that this 3 is going to kick out in front of the 8. So I'm going to have the cubed root of 8 to the 1 power. Right? So that's just to the power of 1. So I'm going to think about my number 8. And I know that 8 is 2 times 4, right? And 4 is 2 times 2. I remember from previously that I'm looking for groups of 3, right? So I have 1, 2, 3 2's, which means that I have one group of 3 2's, which means that the cube root of 8 is 2. Right? If you can't remember this, you can go ahead and Google just simplifying cube roots, right? Or simplifying roots of more than 2, right? That would be a really good place to start. So we're going to keep looking at different versions of this, but generally the same thing. So here I'm going to convert it into out of exponent form and into radical form. So I'm going to take that 6, I'm going to pull it out in front. So I'm going to have the 6th root of 729, which is to the power of 1. Right, so I need to simplify 729. We did this in a couple different ways. Some people use 729 and then they took out a number like the number 3 and got left with 243. Right? And then they looked for another number like the number 3 and got 81. Got another number 3, took out 27. Got a number 3, took out 9, and left with 3 and 3. Right? And then counted to see how many of them they had and found that there were 6. And so we know that the 6th root of 729 is 3. You could have also broken it down this way. You could have said, okay, 3 and 243, 3 and 81, 3 and 27, 3 and 9, 3 and 3, and still said 1, 2, 3, 4, 5, 6. There are 6 of them. We're looking for groups of 6, so 3 must be our answer. Whether you use the factor tree over here or you use the birthday cake method, it doesn't matter which one you choose. You should still get your same answer of 3. Okay. We're going to look at what happens when there's not a 1 there, right? So on this one, we're going to kick our 2 out in front. So we'll have the square root of 36 to the 3rd power. I have 2 options here. I can either do the square root of 36, or I can do 36 to the 3rd power and then do the square root. I know that the square root of 36 is 6. That's a really simple thing for me to do. So then I can just take 6 to the power of 3, type that in my calculator, or do 6 times 6 times 6, and get 216 as my answer. Right? I'm going to do the exact same thing here. I'm going to look for something easy. Right? So I'm going to pull the 4 out in front. I know that it's 81 to the third power. I don't really know what 81 to the third power is, so I'm going to go ahead and look for this, right? 81, I know 81. I'm going to take out a 3, get 27. Take out a 3, get 9. Take out 3 and 3. Right, I'm looking for groups of 4. I see a group of 4 here, so I know that it's 3, and it still has that third power. So 3 times 3 times 3 is 27. 27 as my answer. Right? This is when our multiplication tables are going to come in super, super handy. So we're going to keep headed up here. So this one just looks a tiny bit different because it does have that negative in front there, but it doesn't change anything about our process. We take the 3, pop it out in front, so we have the cube root of negative 64 to the 1 power. To the 1 power doesn't really change anything. But we're looking for things that make 64. So I'm going to start with taking out a negative 4, and I'm left with 16. And then I know that that can be negative 4 and negative 4. I'm looking for groups of 3. So I have 1, 2, 3 negative 4s. So I know that my answer is negative 4. If this factor tree method kind of scares you, you can always go back to birthday cake, which is like this. Take out a negative 4, you're left with 16. Take out a negative 4, you're left with negative 4. Same thing, we see our group of 3 things, which make negative 4 as well. Sweet. So just one more added feature. When I see a negative in front of my exponent, remember that negative exponents create a fraction. So I'm going to have 1 over 729 to the 1/6 power. It doesn't change this fraction because the fraction doesn't create a fraction, which is kind of strange. But the fraction doesn't create a fraction. The negative sends the 729 to the bottom of a fraction. So let's review that really fast. This negative right here, that baby negative, means that we put it on the bottom of a fraction. We don't change anything else about it, so we still have 729 and the 1/6 power. I want to deal with the 1/6 power, so I'm going to take this 6 and pop it out in front. That means that I have 1 over 6, 729. Right? I'm going to remember from up here, because I already did this math, right here, that to the sixth root of 729 is the number 3. Right? So I know that this right here, all of that simplifies into the number 3. So I have 1 over that 3. Right? And that's going to be my answer right here, 1/3. I'm going to do the exact same thing. We'll do another example like this one. So 9 to the negative 1/2. Remember that negative turns the number 9 into a fraction, right? So it'd be 1 over the 1/2 power. I know that 1/2 power is just the square root because that 2 is going to pop out in front. So I have 1 with the index 2. And I know the square root of 9 is 3. So I have 1 over 3, 1 over 3 as my answer. Right? This takes a lot of practice, guys, and is a lot easier when you know your multiplication tables. So feel free to use your calculator for the calculation piece, like when you're trying to figure out what 6 times 6 times 6 is, or that type of thing. But try not to just type it directly into your calculator. You're not really learning anything that way. I will see you guys tomorrow. Bye.